So now we get to the inverse of logarithmic expressions. But to get there, we have to understand the definition of a logarithm. So we've been talking about evaluating, we talked about natural log and common logs. With that knowledge, we finally can get to the definition. So definition of logarithm is given as the log base b of y equals x. And we said by using various examples, if and only if that base b raised to that x gives us the y. So we're going to enclose our statement, our definition of a log, within that statement right there. And now to try to explain the inverse of it all, let's take this function, y is equal to b to the x power, as function of x. So this can be written as f of x is equal to b to the x power. So that's okay. The inverse is when the domain and range is reversed, or they're exchanged. Okay? So the x and the y value basically switches place. Sort of like a multiplicative inverse when you were looking for the perpendicular line of a given linear equation. You have to take the opposite and reciprocal. So in this case, what we have to do is take the y and the x, and we have to change the position so it becomes log base b of x equals y. And we cannot call this f of x again. It'll be kind of confusing with this f of x. So let's call this g of x is given as log base b of x. Now, to show the inverse relationship between the two, we're going to substitute in for the x for the other function of each. That was a mouthful, so let me show that. So what that would mean is, let's test it out. If I say g of x, but the x is going to be substituted by f of x, well, that will be written as log base b of x, but where the x is, we're going to substitute it with the definition of f of x, which is b of x. And the argument is, if they're inverse of each other, the x will come out by itself. And you're like, what? Why? So to see that, let me put some numerical value. For example, what if I say, suppose log base 2 of 2 to the 4 power. See, the b and the b matches with the x as 4. Then I'm saying that's going to be 4. So let's talk about this one. Let's think about this. What this says is log 2 to the what power gives 2 to the 4 power. Well, duh. This one's a no-brainer. What goes in here must be 4. And that is why this expression becomes 4. See that 4? It just came down by itself. So that one works out. What if I reversed it and said f of g of x? Then same thing should happen, right? Because now if I say f of x, which is b to the x power, but where the x is, I'm going to substitute it with g of x, which is defined as log b of x. Stay with me now. And according to this statement, the x should come out by itself at the end, just like when it was g of f of x. And why is that? You cry out, why? Show me the proof. So, how about this time I say, instead of b, I say 3 raised to log 3 of, say, 9. So that the answer will be 9 at the end. So let me demonstrate that one for you. Because up here, isn't that like saying 3 raised to 3 to what power is 9? Well, we know that it should be squared because 3 squared is 9. So if that's the answer for the entire equation, then that will be written as 3 to that answer, which is still 9. Henceforth, that 9 comes down as part of the answer. Either you're totally lost or you somewhat see why the inverse, that these two, the logarithmic form and the logarithmic form and the exponential form are inverse to each other. With that argument, here's how we use it. Simplify. Please note that the base 8 here is the same as the log base 8 here. So, how do you simplify 8 raised to the log base 8 of x? It's just x. Okay, the number 2, you could see right away how redundant or simplified or kind of no-brainer this becomes. All you have to do is identify the base of the entire expression, and if there's a base of a log that's the same, then the x, or whatever that number may be, comes out as a solution. Now how about this guy then? In this case, you would hope that there's a 4 here. Okay? But there isn't. Well, it is in disguise, in fact. Check this out. This can be written as log base 4 of 4 to the second power with the exponent following along. Isn't that the same thing? 4 to the second power, isn't that a 16? And with that being said, the base 4 here is the same as the y value 4 here. So what comes down is just that, 2x. And finally, on this one, yeah, this is also in disguise. This can be rewritten as log base 3, and you want a 3. But how does 3 become an 81? Well, you know, 3 times 3, that's 9, times another 3 times 3, another 9. They multiply, become 81. So it's going to be 3 to the 4th power with that exponent x following along. So now we have the same base, log base b, which is 3, and the 3 over here, the y value. So the exponential form 4x comes down as the solution. Once you start your homework, it'll start to make sense, and when you recognize the pattern, then you'll be able to make the connection